be attempting the hard difficulty, and each of us will be explaining one varying level of difficulty. So to begin, Joey will start off by explaining our selected design principle, favor composition over inheritance. Have it open here in Chrome. And now Joey will explain the principle.
All right, so as Derek mentioned, we are doing the principle of favoring composition over inheritance. To violate this principle, it means that we'll be extending a class rather than composing it. A violation can occur when inheritance is not being used for the purposes of the decorator pattern, although there is one edge case which Derek will go into in his explanation later, or the class being inherited from does not have all abstract methods. And as you can see in this definition, is in this diagram here, there's 6 cases we'll be going over. One of them is the decorator edge case. The first example is just from B composing A. It's just basic composition. Obviously, there's no violation here. Second one is from F to E. There is a violation because it is inheriting method 2 when it could be composing. Third one is a valid from C to D because both the methods in C are abstract. Decorator is just a decorator example Derek will be explaining. The example from J to I is a violation because it both inherits method 2 and overrides method 1. And the example from H to G is just a big violation because it's blatantly inheriting all the methods in G when it could easily be composing. And I'll give it back to Derek now.
And opening Chrome. So before we get into this demo any further, I'll give you the definition, or our group's definition of the decorator pattern. So in order to be considered a decorator, you yourself must have a field of one of your superclasses or implemented interfaces, and you must implement all of the methods defined in that in the component, the superclass or implemented interface that you're decorating. The class node and class visitor get picked up by our favor composition or inheritance analyzer, but we did not declare either of these classes decorators either. So the reason being is that this falls under a specific case where class visitor, which class visitor has an instance of itself. And you'll see this here in this association arrow. This is similar to how a linked list may work in Java, or just in general. So here we do see the detection of the decorator pattern. We have our component, which is an abstract parser, which has some concrete implementation, ASM-based parser, as well as here is kind of like the intermediary level of abstraction for the decorators, the parse decorator, which has an instance of parse decorator or abstract parser, and then here are our concrete decorators: public parse, protected parse, private parse, recursive parse, and these are examples of where they inherit an instance of the thing, or of the component, the thing that they're decorating. Joey mentioned earlier that there was an edge case. Normally we don't detect the favor composition over inheritance principle in the presence of the decorator pattern, and usually we don't declare something a decorator if it doesn't implement all the methods of the thing that it's extending or implementing. But in this case, abstract parser is an abstract class, and it declares a abstract method called doParseBehavior. Now, since parse decorator is also abstract, it doesn't define this method within this class, and it allows the subclasses to handle its implementation. However, it still plays a large role in the subclasses still being decorators because it holds the instance of the component that the concrete decorators need to use to decorate the component. So for that reason, we declare the parse decorator to be a decorator, and since the favorite composition over inheritance and decorator analyzers are ran separately, and we don't try to look for whether something has already been flagged as a violation of a principle or following a certain pattern, or simultaneously, parse decorator ends up being flagged as both. And here we have Java filter sequence decorator. We don't have another intermediary abstract class here between the concrete decorator and this component, but as you can see, it still follows our definition of what the decorator pattern requires. So now we'll move to Andrew.
Which is called the mouse adapter, but as you'll see, the mouse adapter doesn't actually have any instances, it doesn't have any fields on it. So we said that this was not the adapter pattern for that reason. So it's interesting how this works. On the mouse adapter, mouse adapter implements, mouse adapter implements mouse listener, which extends event listener. And mouse adapter has these 8 methods some of them from mouse listener. And these 8 methods are actually blank or implemented as blank implementations in mouse adapter. So the way that they adapt almost these subclasses is these subclasses will subclass mouse adapter and then implement the methods they want. So if you wanted to be a mouse adapter, you could just subclass mouse adapter and say, I only want to do something when the mouse was clicked. You can just override the mouse clicked method and nothing else. And then you can be like a mouse click listener or something like that. So that's how we said. But we said that was not an adapter because it does not have an instance of anything in here, and it does not call that instance. So these are essentially just using inheritance in a clever way, not using the adapter pattern. So okay, so now we are here, and you'll see that the input stream reader extends reader, and reader implements 2 interfaces. It implements closable, which has method close, and readable, which has method read. And you'll see those are both still abstract in the abstract class reader. So read and close. So since input stream reader extends reader, it has to implement those abstract methods. And you'll notice that input stream reader has an instance of stream decoder. This has a arrow here, has an instance of stream decoder. And in the code, in input stream reader's implementations of read, of char array, and int, and close, it actually calls stream decoder methods on stream decoder. So by all means, by all accounts, this should be a decorator, and we thought that it actually was for the longest time. We thought something was wrong with our code until we realized, hey, wait, there's this extension arrow here from reader. Stream decoder actually extends reader, and we said that this is not an instance of the adapter pattern because the stream decoder already extends reader, which means that it's already closable and already readable. Thus, there would be no reason to adapt it to these interfaces. So in our definition as well, if the field that you're adapting is already the interface you're adapting to, that's not the adapter pattern because there's no reason to adapt. It would work and debug. So here we go. So the first one we've got is this dual adapter. So this is kind of like readable and closable, except this is an actual instance of the adapter pattern. So we've got target interface A, which has do A, returns a character, do B, another method, and the dual adapter implements both of these methods because it implements both of these interfaces, and it's got an instance of the needs adapting class, and needs adapting is called, or methods in needs adapting are called in both do A and do B, so do 1 and do 2 respectively. So that actually is an adapter. So you'll see In this example here, we've got the target interface, which has 3 methods, do A, do B, do C. Same thing here, we've got an adaptee. It implements these 3 methods with calls to the adaptee, so that is an adapter. Now, I also include an example here where do C actually doesn't have, it's the same thing, but do C doesn't have a call to the adaptee, thus it is not an adapter. And if I go in the code really quick, then it will be an instance of the adapter. Yep, see, and that has changed because now it satisfies our requirements for the adapter. And that is all the tests that we have run for the hard part on our project. So I don't think we have any further demos for you. And I'll give it back to Derek for the outro.
Okay, so those were all of our demos in our project.